Dead. Okay, the recording has started again. Please mute your call. What's up, guys? Please. Oh, yeah, so so I said that who wants to tell us what we did yesterday? Someone should volunteer to tell us what we did yesterday, please. Someone should do that. What's the name? Esther Success. Esther Success, please. Are you on this call? Please unmute your mic. Esther Success. You are not there, Abi. Azan, are you there? Ah, Mr. Wera, Okunola, Musopo. Please, you guys should react if you are on this call. React with a thumbs up or level emoji. React, please. If you're on this call, react. Treasure, Toluwani, Wahab, Aishat, Timothy, Aibami, Samuel Leyo, Paul, Adekunle, Oyetayo, Oni, Emmanuel, Okunola, orúkọ tán àbí what's this? Ọlọ́run mọ́nú mi. That name tough. That name is sweet and tough. Kevin P, Catherine, Itibo, Kadejo, Iyanoluwa Adeyemo, Azan, Oluwatosin, Hafiz, Godwin, Francis, Benga Daniels, Farouk, Yusuf, Okon, Favor Alexander, Falola Favor, Faith Manshak, Jiwu Manshi, Mamanchi, Mamanchi, Fadekemi. And so I think I've been able to call everybody's name. So I believe everybody's there. So please, if you hear your name, please make sure you react. Make sure you use love emoji. Use the love emoji if you hear your name, please. If you know you've heard your name, use love emoji, please. Esther Success, Okwara, Okoro, what's the name of this name? Okoro Ahmed, Musokpe, Sobsi, Sosi, is Sosi, Sosi, Musokpe, Abdurrahman, is it Rahman I know in medicine? Is it Rahman in medicine? You can just use the comment section, please. Is it Rahman in medicine? Abdurrahman? Huh? Please unmute your mic, Abdurrahman. Akeola, Aliyu, Namaste. Amidas Batunde, Creed 004. So Kadejo doing solar heritage. You want to say something? Raise up your hand. Doing solar, you raise up your hand. Do you want to say something? Doing solar, do you want to say something? Raise up your hand.
No, sir. No, sir. I'm not saying
Okay. So please lower your hand, so it's not confusing me. Lower your hand. Okay, so please just lower your hand if you are not saying anything, please. Very important. Okay, so good. Shemilore, you joined call today. Egun Shala. Shame.
Good evening, sir.
You joined call today. Oh.
Yes, sir.
You na boss lady now. Yeah, scholar. Scholar, no dey whine me. Scholars can do and undo. Scholars can do and undo. So tomorrow, we don't know the next time we'll see again in this call. So Joshua, I hope you shall share the link, Shemilore, so that you join call today.
Sir.
Let's see your
Yes,
usefulness.
sir.
May
Sir?
days. I said this one that you join call today be useful.
Okay, sir.
Good. Okay, so now, so I said that yesterday, I said someone should help us to talk. Maybe Faith, Manshak, unmute your call, unmute your distance and talk. What are the things you learned from yesterday? Be fast, please. You have 2 minutes.
Yes.
Tell us all the statements you learned. Don't do as if we know anything. No. So you explain to us like we don't know shit, like our head is empty. She gets. So yeah, explain everything you learned yesterday as if we don't know anything. Yeah.
Okay, we started with electric charge.
Okay.
We talked about the net charge in a body being quantized, and it is the combination of proteins and electrons in the body. We also did where the formula Q equals to Ne, where Q is the electric charge, N represents the number of protons, and E is the elementary charge. And elementary charge is a value of 1.602 times 10 raised to the power minus 19 Coulomb. We also talked about quark, and you said something about quark being the smallest particles on Earth. Um, Before that, talked about electrostatic series.
Please let's clap for her. Let's be clapping for her. She's talking. Let's that because she's encouraging. You can use the clapping reactions. We also continue, continue.
Before that, talked about the electrostatic series, and you gave us a list that started from the ones that are weak, to the strong ones, and you gave example of glass and fall. If glass and fall are rubbed together, which one would lose electron and which one will gain electron? Glass obviously will gain electron to become positive. Will lose electron to become positive, while fall will gain electron to become negative. Then you talked about charging of an uncharged particles. You said there are three ways an uncharged particle can be charged: by friction, by contact, or by induction. Then we went to Coulomb's law. One of the statements you made was all neutral bodies are attracted to charged bodies. We went to Coulomb's law, and Coulomb's law states that when two charged bodies are brought together, there exerts a force that is directly proportional to the product of the two charges and inversely proportional to the square of their separation. You then said if two charges are of the same sign, they will experience a force of repulsion, and if the two charges are of different signs, they will experience a force of attraction. You made another statement saying that charges are conserved, which means that the total initial charges on each body in a system equals to the total final charges in a system, meaning that charges can never be created, but they can be transferred. Then you gave examples which we're solving. That's all.
So let's though I think she just summarized it actually, and that's good. At least she talked about some of the things, most of the things she remembered, and also you were using your notes. I was expecting you to actually use your notes to tell us the things that you
Yes,
get. I
I
was
used my notes. I just summarized it.
okay, use your notes like the stuff you
Yes,
just down your notes. Okay, that's good because I was expecting you
yes.
to use your notes, not your head totally. She gets and I was even trying to move this move the materials to the things we were talking about. She gets so that
Oh,
at least people can follow along. So that is it. So that's those are the things we talked about. So we talked a lot about a lot of things. We talked about she just summarized it. We did a lot of things. That yesterday was like 2 hours, 30 minutes class. So we talked about electric charges, we talked about it in details, and the fact that we have the positive charge and negative charge. The positive charge is like a boy, and negative charge is like a girl. And boy and girl they will attract. So plus or minus will attract. That's unlike charges will attract. Then boy gay they will repel. So that means plus plus will repel and minus will repel because girl too will repel. She gets those are the things. Those are so many of those things we talked about. She gets that we can't have girl minus attracting. They will be repelling because girl and girl they will not be any attraction. That's gayism. So then apart from that, after talking about charges, I talked about the fact that charges are quantized, which means that charges are integer multiples of elementary charge. Elementary charge is the smallest value of a charge, smallest value of a proton or an electron, which is 1.602 times 10 to the power minus 19 coulomb. That's the elementary charge. So all of that charges are integer multiples of the elementary charge, which means Q equals to NE, where N is the number of protons or electrons in a body, and E is the elementary charge, which is charge of one proton, which is 1.602 times 10 to the power minus 19 coulomb. Charge of an electron too is the same thing as charge of a proton. They have the same value, just that the sign is different. Proton is positive, electron is negative, but they have the same charge value, which is 1.602 times 10 to the power minus 19 coulomb. Take note of that. So now, apart from that, we also talked about the fact that we talked about the fact that charges are conserved, which also she has talked about already. Charges are conserved in the sense that charges can neither be created nor destroyed. You cannot create charge, you cannot destroy it. You can only transfer it from one body to another, one body or particle to what to another. So in other words, the total number of charges in an isolated system can never change. So it means that if you rub me with someone else, both of us will exchange charges. And when we exchange charges, the total amount of charges is fixed, because charges cannot be created nor destroyed. So if I rub myself with someone else, we are going to exchange some charges. We are not creating it, we are not destroying it, we are only exchanging it. So you get, and that is one of the ways you can transfer charges is by rubbing. When you rub two things together, there will be warmth. No, you know what I'm trying to say now. So there will be transfer of charges. So that is what's just happening. Charges are just being transferred. It's not like maybe we are creating it or maybe we are destroying it in one, or no. And one of the things that conservation is talking about is that before I hug someone, let's say that the charge on me is zero, charge on the girl too is zero. What's total charges before hugging? Zero plus zero, that's zero. Now after hugging someone, let's say the charge on me is now -5, because maybe I lose some electrons to whoever I hug. So let's say charge on me is -5. The charge on the no, say let's say charge on me is +5, and the charge on the girl is now -5. The girl got electrons from me, so she's now having -5. Why me I'm having, mean that I'm losing electrons to the girl, mean that I'm losing money to the girl. I'm having plus 5. So now at the end of the day, after the hugging, +5 and -5, what's the total charge? It's still zero. So before hugging, before I met the girl, the total charge was zero. After I met the guy and I hug and I lose some electrons, the total charge was still zero. And that's what we're trying to say about conservation of charges. That charges are always conserved. So you get, so just like money, so say our money is conserved, because obviously if you meet someone and you cannot say you destroy the money. If I meet a girl and she rip me and she collect my money, Wagbo Mija or something, in that case, the money did not destroy, because obviously women love money, they can't destroy money. So she did not destroy the money. She collected the money from me, which means the money was transferred from my hand to her hand. So which means that this thing is still conserved. Are you guys getting my point now? Which means that this thing is still conserved, which means that there's still conservation. There's still conservation, because the money, I don't know if you guys are hearing me. Okay. Are you guys hearing me like this? Please give a reaction if you are hearing me. Give a reaction. Okay, thank you. So now, I was trying to say that if it just charges just like money. So if I give someone money now, obviously the money is not based on, I'm not destroying the money. I'm only losing it. Like I'm only transferring it. I'm losing it, so I'm transferring it to the girl, which means I am losing it, but it's not destroyed and it's not created, because it is just moving up and down. So that is just what is going on. So that's exactly what is happening in charges too. The charges are not created, it is only being moved up and down. So you get that kind of thing now. So thank you for that. So now that's what conservation was talking about. And I talked about this reactive decay where I talked about the fact that you look at this now. We have a decay here. We have a disintegration. So uranium disintegrated to, if you look at the screen, uranium disintegrated to what? To thorium. So now, but what happens is that even though there was disintegration of the radioactive elements, the charges are still conserved, because if you look at the left hand side of this equation, the proton number is 92. Abi, now at the right hand side, what is the proton number? 90 plus 2, that is what? 92. So it means that the proton number at the left hand side equals to the proton number at the right hand side. Even though uranium has splitted, it is still preserved, it is still conserved, because the numbers did not change. That is what they call conservation. So conservation is just saying that we are not manufacturing it, and we're not destroying it. We're just transferring it. And while we're transferring it, it is just moving from one form to another, which means it is conserved. It is not disappearing and it is not appearing. It is not juju. Shey you get? It's not magic. It is not disappearing, it is not appearing. No, but you cannot just wake up and see money in your house. It's not possible. Shey you get? You have to work for the dime money, for the money, or someone will dash you. All these kind of things. So money cannot just disappear. Money cannot just appear. You have to work with it. It's like they are working up. They are pushing. So that's exactly about that. So now the other one I talked about again was the fact that there's something called pair annihilation. Pair annihilation means that two particles come together and they cancel out to produce energy. Pair annihilation means when two things come together to produce energy. When a particle and its antiparticle comes together to produce energy, that is pair annihilation. So you get, that is basically what pair annihilation is. Then the other one again is pair production. The opposite of pair annihilation is pair production. In pair production, in pair production is the opposite of pair annihilation, whereby in pair annihilation, two things come together, they destroy to form energy. Gamma ray means energy. When you hear gamma ray means energy. So two things annihilate. Two particles come together. Like here now, electron and positron came together. They cancel out each other and they form energy. In pair production, it is the opposite of what is annihilating. In annihilating, particles are destroying to form energy. But in production, energy is being used to form those particles back. That is, you are producing a pair of particle and its antiparticle. So that is the opposite. So then we saw questions on Coulomb's law, which is we solve some questions, which is for Coulomb's law is Coulomb's law formula is KQ1 Q2 over R square. So we solve questions on Coulomb's law and we and like that. So we call it a success. So that is exactly what we did basically. So if you have any question, you can raise up your hand and talk, or you can use a crying emoji. If you have any question, no, you can use a crying emoji, or you can raise up your hand so that I can call you. And do you want to say something? Heritage. Heritage, you raise up your hand. Do you want to say something? Fade Kemi, please unmute your mic. You use a crying emoji now. Fade Kemi Sola, please unmute your mic also. Do you want to say something? Please be fast, be fast. If I say you unmute your mic, you have just 10 seconds to do that. So please.
No, it was a mistake.
The kind emoji was a mistake. What about Doinsola? Adejo, Doinsola Heritage. Do you also have something to say? Because you raise up your hand. Do you also have something to say? Doinsola? Adejo, Doinsola Heritage. Do you have something to say? I'm bringing you down. Okay, good. So let's continue then. So please don't raise up your hand if you know you don't have anything to say, or else you'll be removed from the call. So that means you have to rejoin back. So now, let us now continue. Like say yesterday, we solved questions on Coulomb's law after talking extensively about the statement part of this course, which is we talked about. Like I said, we also talked about conductors earlier. She didn't mention it. It's conductors. We talked about conductors, semiconductors, superconductors, and insulators. And I told you that among those four materials, which one do they use to make your iPhones, your computers, you can use the comment section, please, or you can type it on the group. Which of the particles do they use? Yeah, I'm waiting for you guys to type. I'm asking a question. Yeah, so Akela, God bless you. So semiconductors are what they told you that they asked last year. They asked the question last year. They were like, which of the following is true? What they even said in the statement was they said superconductors are used for computer chips. Is that correct? No. Superconductors are not used for computer chips. It is semiconductors that are used for what? Computer chips. So that was a trap they brought last year. They don't use superconductor for computer chips because it has zero resistivity, so it cannot work as a switch. Cannot work as a switch. She gets. So you don't use superconductor for stuff like that. But if you need something that can work as both a conductor and an insulator, that is semiconductor. Semiconductor is like is in the middle of conducting and insulating, which means it can be made to function as an insulator and it can be made to function as a conductor by doping it and adding impurity. So those are the things you need to know. So you can easily use conductor you can make it to act as a switch, just like your transistor, your diode, and all those things, which we've talked about yesterday. So please see that yesterday video, it will be on the YouTube, so you can go through it in details because we talked about a lot of things which I cannot go back to again now. So you can go through I will send you the link after the upload. So just make sure you use the data saver and make sure that I believe everybody knows how to use it. You can fast forward on YouTube. So if you are using YouTube to watch anything, it's like it's over 2 hours video. So you can just fast forward it. There are some parts that maybe you understand already. Just forward it to the parts you don't know. Or maybe you can use the double speed. I used to do that one too. You can put it at X2. You can increase the video speed. So those are the ways you can maximize. The video is 2 hours 30 minutes. We didn't cut any part of it. So which means you can easily cut out the part you want to cut by yourself. You get my point now. So That's that about that. So now let us look at these examples we did yesterday. We did this example yesterday, whereby we did examples on Coulomb's law, whereby our formula for force is KQ1 Q2 over R square. And or I know this formula is from Coulomb's law, whereby Q1, whereby if you have two charges will exert force on each other, and it can be force of attraction or force of repulsion. And when can it exist? When can we have force of attraction? Have force of attraction when are you guys you can have force of attraction when you have a scenario whereby charges are of different sign. Let's say one is plus, one is minus, there will be force of attraction. And if the charges are of the same sign, it will be force of repulsion. So those are the things we talked about. She gets which is called the
Good evening,
superposition form. Someone say something. Absalam, do you want to say something? Absalam, do you want to say something?
I wanted to ask that, are you going to send this thing to us like a full video to us?
No, no, I said I'll send the YouTube link. That's what I said. I'll send the YouTube link. So you guys
Okay,
can go to the YouTube link and you can fast forward it to the part you need. Do you understand my point now?
so no problem, sir.
So you don't need to obviously watch it in full. Just fast forward to the part you need. So you get that kind of thing. So, so do you have Absalam, do you have any question again? Abu Samad, do you have any question? You raise up your hand now. Abu Samad, you are raising
That's
up your
all.
hand. Eh?
That's
Okay. I just want to confirm. Because I saw that you raised your hand up, so as I'm asking. Okay, so that's thank you. I think you said that's also. I think we are good. So please, that's that about that. So now I talked about superposition theorem yesterday. Superposition theorem is just it's a theorem that is used to add forces together. She gets so now Coulomb's law, Coulomb's law is only used for when you have two charges, charges one and charges two. She gets. But what happens when you have like four charges, or when you have five charges, or when you have 10 charges? In that case, Coulomb's law cannot be utilized. I guys hearing me now. No, Coulomb's law can be utilized, but it cannot be utilized directly. You cannot just say F equals to K Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q7, up to Q10. You can't do that in Coulomb's law. So what you can do is that Coulomb's law only allows you to pick two charges at once. Coulomb's law only allows you to pick two charges at once, which means that if you want to use, which means that if you want to use, if you have like 10 charges, you have to use superposition theorem, which says that the total force acting on a charge equals to, like, I give an example yesterday. Someone can help me tag that picture. That picture that I sent to the group yesterday that has four charges like this. Someone can help me send it back. There's a picture I sent to the group yesterday that has four charges that I drew. I drew four charges. So if they tell you to find the total force on charge one, let's say you have four charges, Q1, Q2, Q3, and Q4, and they say find the total force on charge one due to the other charges, what you will do is that you say the total force on charge one due to other charges will be total force on charge one due to charge two plus total force on charge one due to charge three plus total force on charge one due to charge four. Take note of that. So if you have four charges now, it means you are going to have total force on charge one due to two, total force on charge one due to three, charge one due to four. So that way you have force on, that means you're going to be adding three forces together like that. She gets. So that's superposition theorem. She gets. So then you now apply the principle of direction and you apply the principle of magnitude. What's the magnitude? Take Q1, Q2 over R squared, then you apply all those things to solve it. So we did all those ones yesterday. Please, you can make sure you watch the video when after this class, you can go and watch the video so you can get to understand it in details. Because I explained all these things in details yesterday. I explained in detail and I made sure everybody understood. The people that don't understand, they gave a crying emoji. And I made sure I explained again and again and again and again till everybody understood what is going on. So you get. So please, now let's now go to the exercise question. Exercise. Probably before I move to the exercise now. Look at this example 1.5 that we did yesterday also. We have charges Q1, Q2, Q3. So they said we should find total force acting on charge Q2. So I will use the superposition theorem, which says total force acting on charge 2 will be force on 2 due to 1 plus force on 2 due to 3, which is what you are seeing here. Total force on charge 2 will be force on 2 due to 1, force on 2 due to 1 plus force on 2 due to 3. So that is basic superposition um principle that is in play. So you get, so please, like I said, go through the yesterday's, we explained all these things in detail yesterday. So just go through the YouTube video when I drop the link this midnight. So now exercise 1 now. So let's look at exercise 1. For this exercise 1, we said given the diagram below. This was the assignment I gave you guys yesterday. So given the diagram below. Hi guys, please give a thumbs up if you are following this. Give a thumbs up if you are actually in this class, like a love emoji or a thumbs up if you are actually part of this class. She gets okay, good. So example 1.1, which we did yesterday. Hi guys with me. Example 1.1, which we did. God will bless this girl. That who is this person? Let me see the name. Okay, E digits. God bless you for sending the distance to the group again. For people that went on the group call yesterday. So this example 1 is this exercise 1 that I gave you as assignment yesterday. Did anybody even try to do it? If you did it, you can give a clapping emoji for yourself. If you solve this question, if you actually solve it and let's say you attempted it, you don't get that, so you attempted it, give a clapping emoji if you did that. Clapping emoji if you do that. Nobody. So nobody attempted this question. Nobody attempted this question. Faith, where's again? If you attempted the question, please give a client. If your network is not good for Google Meet, please join the WhatsApp video link. If your network is not good for Google Meet, please join the WhatsApp video link. Anyone is fine. If your network is not good for Google Meet, your WhatsApp should be going at least. Okay, I am doing so. Like you also did the assignment, right? Where's again? If you did the assignment, please give a clapping emoji. Azan Afis. Okay, now if you actually got the answers and the answers correctly, give a clapping emoji for yourself. If you solved it and you got the answers correctly, give a clapping emoji. If you solved it and you got the answer, give a clapping emoji. Please and please, like I said, if your network is not good for Google Meet, join the WhatsApp call. If your network is not good for Google Meet, join the WhatsApp call. So please, if you got the answers correctly, give a clapping emoji. If you got the answers correctly, like you did this question and you got the answers that are here correct. Okay, good. I am. So Faith, did you get the answer correctly? You did not clap. Azan, Faith, you could not clap. So that I assume you guys did not get the answer. Okay, so now if you want to solve questions like this, what you do is, please, if you have not shared the link, make sure you share the link if you have not done that. So now let's continue. What you do is this: if you have a question like this, you have charges Q1, Q2, and Q4. Let me zoom it so that you guys can see very well. Let me try to zoom the question. So can you guys see? Can you guys see very well? Can you guys see the diagram very well? Okay, good. So now looking at this, we have charges. Q1. We have charges Q1, Q2, and Q4. This Q4 should be like go straight melee. So charges Q1, Q2, and Q4. Now, distance between Q1 and Q2 is R. Distance between Q1 and Q4 is 3/4 R. Distance between Q1 and Q4 is 3/4 R. And what is the value of R? We said the value of R is given already to be 0.2. And they gave us our theta already. They take theta to be 60 degrees. So theta is 60 degrees and our R value is 0.2, which means I can put 0.2 here. So I'll say 3/4 times 0.2. You can get the distance between Q1 and Q4. Then distance between charge Q1 and charge Q2 is R, which is 0.2, which they've given us already. She gets. So now they said we should take our Q1 to be E and our Q2 to be 2E. That's plus 2E. Then our Q4 to be minus 2E. Where the value of E is 1.602 times 10 to the power minus 19 Coulomb. I've told you before, E is the elementary charge. So it is a fixed value. So we know the value of Q1, Q2, and Q4 already. She gets. Thanks for sending a love emoji. I love that. So shows you are following me. So now, how do we solve this? What you need to do? Want to say something? Amidat, who is this Amidat? I mean, please, if you are joining the comment, let me remove this one. Amidat is not serious. Let me remove whoever is disturbing this class. I will remove the person. If you want to talk, raise up your hand or give a crying emoji so I can call you to talk. If you talk without asking, without me telling you to talk, you are leaving the call. I will block you from the call totally. You will not be able to join again yourself in the future. You are gone forever. So now, so as I was saying now, so what I'm trying to say is this. I said we have our charge. The distance between Q1 and Q2 is R. Distance between Q1 and Q4 is 3/4R. She gets. So now they said we should find. The question says find the electrostatic force on particle 1 due to particle 2. Find the force on particle 1 due to particle 2 and particle 4. Find the force. Find the force on particle 1 due to particle 2 and particle 4. Can you guys see the question? So now, this kind of question now is intriguing. They want us to find net force. So using the superposition formula, what does superposition formula say? The superposition formula says that the total force on 1 will be force on 1 due to 2 plus force on 1 due to what? Due to 4. Do you guys agree? Total force on 1 will be force on 1 due to 2 plus force on 1 due to 4. That is the formula for doing that. So you get. So are you guys following me? So force on 1 due to 2 is what is the direction? Force on 1 due to 2. What is the direction? This is charge 1. This is charge 2. Now, charge 1 is positive. Charge 2 is positive. Plus, what happens to them? Then you guys should use the comment section. What happens to plus? They will repel, right? So since the plus will repel, it means you can use the comment section to type answers to any question I'm asking. So plus will repel. It means force on 1 due to 2. Will it go and meet? Will it be attracted to 2, or will it run away from 2? 1 will repel 2. So this one, so 1 due to 2. 1 will move away from 2, right? So 1 will move away from 2 in this direction. So 1 will move away from 2 in this direction. So you get 1 will move away from 2. So it means that which direction is 1 moving away from 2? 1 is moving away from 2 and is moving towards which direction? Anybody? Comment section. 1 is moving away from 2 in the God will bless Akela. 1 is moving away from 2 in the negative x direction. 1 is moving away from 2 in the negative x direction, which means that the direction for force on 1 due to 2, the direction will be negative x. Are you following me? Now, what about the direction for force on 1 due to 4? Force on charge 1 due to charge 4. Force on charge 1 due to charge 4. How do we get the direction? Will 1 go and meet 4? Who is that? What's going on? Who is that? Who is this? Who is Manese Eile? I'm removing him from the call. Thank you. Bye-bye. Go home to your families. So once you constitute new stance, I'll send you home to your families. You're already at home, girl. Or you don't send you home already. So force on 1 due to 4. Since 1 is plus and 4 is minus, there will be an attraction, which means charge 1 will go and meet charge 4, right? Do you agree? Attraction. Charge 1 will go and meet charge 4. Take note of that. So which direction is charge 1 going to meet charge 4? Which direction? The direction is what? The direction is along positive x and positive y, which means force on 1 due to 4. We have a direction along the positive x and along the what? The positive x. That means force on 1 due to 4. We have both I and j values. Okay. Now, I told you something. You can draw a table in your notes. I want to draw a table to solve this thing. Draw a table. Everybody should have their notes with them. Please bring your note out if you don't have your notes. Draw a table. I want to teach you something. Bring your note out. Draw a table. So the table you are going to draw now, the table will have 3 columns. You know what they call columns? The table will have 3 columns. The table you want to draw will have 3 columns. So The first column you put components. The second column you put horizontal components. The third column you put vertical components. So we are going to be having horizontal component and vertical components. So now the first column is the first component, like the forces. Now there are two forces here. Force on 1 due to 2 and force on 1 due to 4. So there are two forces. So those two forces now you put it in each row in the table. Those two forces you put it in each rows in the table. Are you hearing me now? So what you are now going to do is this. So this is what you are doing. The first force you put in the table will be, I hope you are writing this thing, sha. Give a thumbs up. The first force you put in the first force you put in the first row is force on 1 due to 2. Now the horizontal components for force on 1 due to 2 is, we say, well, no, I told you that force on 1 due to 2 is going along which direction? It's going along negative x direction. So it means that the horizontal component of force on 1 due to 2 will be minus kq1 q2 over r square. Force on 1 due to 2, it means you are dealing with charge 1 and charge 2. That means I want formula linking charge 1 and charge 2 in Coulomb's law. F equals to kq1 q2 over what? Over r square. So the original component for force on 1 due to 2 will be minus kq1 q2 over r square. Why is it minus? It's minus because horizontally, force on 1 due to 2 is moving horizontally along the negative x direction. So that's why we're having minus. Shake it. Take note of that. Now, normal, I'm meant to have cos theta for horizontal, sin theta for vertical. I'm not putting cos theta for f12 because force on 1 due to 2 is moving directly on x, on negative x. So there's no need for you. So there's no need for you to cos theta because it is moving only on what? On x. Please note this thing. Note this statement. If you are resolving forces, I want to take note of this thing. If you are resolving forces, if the force is directly on x axis, don't bother to put cos theta or sin theta. Shey get? Just put the sign. But now, assuming the force is moving in between x and y. Assuming the force is moving between x and y, it means the resolution in the table, we have both cos theta and sin theta. Cos theta will be for the horizontal component of that force, and sin theta will be for the vertical component of that force. Meaning that, for example, now, force on 1 due to 4, force on charge 1 due to charge 4. The force is moving, charge 1 will go and meet charge 4 along the positive x and positive y. So it means that force on 1 due to 4, we have a component along the x, and it will have cos theta, and the component along the y will have what? Sin theta. Take note of that. So force on 1 due to 4, it will now be what you are going to have for that one. So you can write that one down. Force on 1 due to 4 for your table. In your table, the next row in your table, just write F14. Force on 1 due to 4, the horizontal component will be plus kq1 q4 over r square cos theta. Then the vertical component will be plus kq1 q4 sin kq1 q4 over r square sin theta. So what we are doing here is that the horizontal is carrying cos theta and the vertical is carrying what? Sin theta. Make sure that your theta is touching x axis sharp. Very important. If you don't understand what I'm saying, you can give a crying emoji. If you don't understand what I'm saying, give a crying emoji. So that if you understand, give a thumbs up or a love emoji. But if you don't understand what I'm saying, give a crying emoji. So you get. Okay, so I believe that with this we can easily continue. So now, who is giving a crying emoji there? Portugal. Please unmute your mic.
What's
Portugal.
the
Portugal, unmute your mic, please. I thought you give a crying emoji now. Yeah, Fadekemi or Fadekemi Sola. Unmute your mic, please.
what's the horizontal
Speak louder, please.
component
Speak
for
louder. Speak louder. Speak louder.
I said, what's the horizontal coordinates for first one due to two?
I said the horizontal is minus KQ1 Q2 over R square. Why is it minus? It's because Q1 and 1 and 2 they will repel. So one will move away from 2 in negative x direction. Do you understand? Can you hear me? Fadikemi.
Yeah, I
Fadikemi,
can
unmute
hear
your
you, sir.
mic.
Go on.
Fadikemi,
Go on, I can hear you, sir.
do you understand what
I
I'm
can
saying
hear
now?
you.
You can hear me,
Can you
but do you
please come
understand?
again?
Do you understand now? Do you now understand what I'm saying?
Yeah, yeah.
Fadi, Fadike, Fadike, talk now. Voila. You should talk now. So let me screenshot. Let me try to screenshot let me try to snap this thing to you guys. Um, so I want to try and snap. WhatsApp guys are lucky. They're the ones that will first. The ones that will first be seeing what I want to snap. WhatsApp guys they'll be seeing my hand as I'm explaining on the screen, and they always be the first to see anything I want to write. The WhatsApp guys. So I want to send this thing to the group. What I just wrote now. Let me send it to the group. Please hold on a second. Give me some seconds. Okay. Jesus, my camera is not working because I'm already doing a video. So I don't know. Who's on what's on WhatsApp? Who can help me to screenshot this thing? What's up, guys? Anybody on WhatsApp that is fine. I'm coming. Anybody on WhatsApp tell me to screenshot this, please? If you're on WhatsApp, help me to screenshot this stuff that I. If you're joining from WhatsApp call, screenshot this stuff that I do. Nobody. This WhatsApp people are very useless. I will soon disconnect WhatsApp call now. They're not following me. WhatsApp people are not following me. I will soon disconnect the call because now like this I can see so many. So I can see like 10 people on WhatsApp, and they're not even screenshot anything. They're not like helping me to snap anything. I'll use my second phone then. I'll use my second. So please use my second phone to send the what I drew to the group. So just please give me some seconds, please. Let me activate my second. Give me some seconds. Okay, so now looking at this now. So I'm coming. I'm trying to use my second phone to snap this stuff to the group. Okay, so now I've sent it now, so you can check the group. Check the group for what I just sent now. So now what I'm just trying to say. So what I'm just trying to say is that your F12 is moving towards negative x, and your F14 is moving along positive x and positive y. So that's what I'm trying to say on the Google Meet. She get. So so now I believe you have seen this thing, what I sent to the group. I believe everybody have seen it. So now what happens here is that if you are not drawing your table now, F12 is moving towards negative x. So it means that the horizontal component for F12 we carry minus. So that means the horizontal component for F12. Let me even draw the table for you guys and send it to the group. So that means that you have a table of 3 columns, like I said. The first column will be for forces. The second column will be what? The horizontal component. and the third column will be for the vertical component. So the first force that we have here is F12. And as F12, we have horizontal component of minus KQ1 Q2 over R square. Where the R will be distance between 1 and 2. Now, the vertical component for F12 is 0 because F12 is not moving along Y at all. It's only moving on X. And it's moving in negative X. But if you look at F14, F14 is moving along positive X. F14 is moving along positive X and positive Y. It means that the horizontal component of F14 will carry plus, the vertical component will carry plus. Now, what will be the value? The original component for F14 will be plus KQ1 Q4 over R square, where R is distance between 1 and 4. Then you add cos theta. I've told you already. If your force is moving along X and Y, always apply cos theta and sin theta. Cos theta will be for the horizontal, sin theta will be for the what? Sin theta will be for the vertical. Take note of that. So vertical component for F14 will be KQ1 Q4 over R square, where R is distance between 1 and 4 sin theta. So that is just, so let me now send it to the group so I can see what I want expected you to do. So I will send it to the group now. So please check the WhatsApp group so you can see what I sent. So check the WhatsApp group so you can see what I sent. So what I just want you to do now for me, after sending this table to you, what I want you guys to do for me now is I want you guys to now help me to put in the values of Q1, Q2, R, theta, and all those things. Put the values in the table and get the answer. Put the values in the table and get the answers for the total horizontal force and the total vertical force. So I want you guys to get the answer for the total horizontal force and the total vertical force. That's what I want you guys to do now. So please check the group for the table and give me the answer for the total vertical force and the total horizontal force. So have you all seen it? Have you all seen the table I sent to the group? I just draw the table now. Yeah, someone asked the question now. Someone said, does F12 only has X components? Yes. F12 is moving only on the negative X. F12 does not have Y components. It's only moving on the X and it is negative. But F14 is moving along X and Y. So it is having both horizontal components and vertical components. Meaning that the horizontal component for F14, like I said, will be, it will have cos theta, which will be plus KQ1 Q4 over R14 square cos theta, plus then the vertical component for F14 will be KQ1 Q4 over R14 square sin theta. So those are the things that we have for the F1, for the F12 and the F14. So please, do you guys have any question? Please, so someone should help me to complete this table. Someone should help me to complete this table and send it to the group. Complete the table says that put the values there. Put the value of Q1, Q2, R1, put the value of theta and everything. They've given us already. Q1 is E, Q2 is 2E, Q4 is minus 2E. For that Q4 now, don't bother to put that minus 2E, just put 2E for Q4. Then put the value of R12. R12 is 0.2 meter. R14 is 3 over 4 times 0.2. So put their values. Then after putting their values, get the total horizontal value and get the total vertical value. So what are you guys obtaining? If someone should do that in 30 seconds. Shemilori, are you on this group? Shemilori, oh yeah, you are the one that used to press calculator for us in normal class. So come and help us to solve. Come and help us to press calculator for this one. Oh man, chic. Shemilori has left this call. Oh my God, serious. Man, sharp. Oh yeah, so maybe you should do it for us. Be fast. Do it for us. Help us to complete the table and put the values. Or who wants to help us? Anybody should. What's the name of this guy? This senior man guy. Digits. Oh yeah, do that. Shalus, you know it's not on the course today. Digits. You can complete the table and help us get the total final answers. Oh yeah. Wait, I'm waiting for you guys now. Nobody. Eh? Anybody? So nobody's helping us like this to like the answer is already even yourself. Normal, the answer is already here. You are meant to obtain, if you check this thing, you have to obtain for your total for your total horizontal value, you should obtain minus 1.25 times 10 to the power minus 25 newtons, and for your total vertical value you should obtain 1.78 times 10 to the power minus 24 newtons. So this is your x and this is your total y value. Now the magnitude, how do you get magnitude? You want to get magnitude, you say your magnitude will just be square root. The formula for magnitude or resultant is will be square root of the x part square plus the total y square. So for your magnitude now, the total x you square it plus the total y you square it, then find the square root of everything all together. That is how to get magnitude. Let me send that one to the group also, so that you guys can do it and get the answer. And if you want to get direction, the formula for direction of the resultant, formula for direction is tan inverse of the y total y, that's y component total y, divided by x component total x values. She gets. So let me send that to the group as well, so that you guys can. So please, I'm waiting for someone to solve this for me. I'm still waiting for Faith. Have you any of you guys to solve what do you call it? To help us to complete the solution for this thing, please. I wait for you. Please be fast, be fast. I want someone to do this thing ASAP. So please, I'm still just trying to wait for you guys. Shake it. So please. I'm waiting for someone to complete this table, send it to the group. Faith. Oh yeah, I'll do it. Do the complete table and send it to the group. So now let's move on. That's that about that. So if you don't understand this, please give a kind emoji so I can explain again before I move to the next question. If you don't understand, talk now so that I can explain it. Give a kind emoji if you don't understand, please. Oh yeah. Oh. If you don't understand, crying emoji. If you understand, thumbs up or love emoji. If you understand, give a thumbs up or love emoji. Ajande. I can't see this name very well. Ajande. Oh yeah, unmute your mic. Ajande, unmute your mic. Momo Emmanuel, you raise your hand. I wanted to talk. Momo Emmanuel, please talk now. Ajande, unmute your mic and talk.
Good evening, sir.
Yeah, good. So where are you having challenges? You say you use kind emoji, so which means obviously you don't understand what I did. So where do you have challenges? You are not this is your first class, Adam.
No, I'm just calling, sir.
That's what I'm saying, that you've not been attending our classes. Eh?
I attended the one of yesterday, the one of MTA, that is function.
No, yesterday was not. Day before yesterday was not. I mean, no, sorry. Yeah, day before yesterday, not yesterday. Day before yesterday was. So my own is just that. Um. So I said that where are you having challenges in this particular store? Where are you having challenges?
The magnitude aspect.
If someone should send the group link to the comment section on Google Meet. Someone should send the link to the group. Someone should send it to the comment section on Google Meet. ASAP. Faith, please do that. Faith, send the group
Yes.
link. The group link is in the group description. Just copy it and drop it on the comment section for Google Meet, so that people that are not, some people are not on the group. Some people are not on the group. They
Someone has
just
dropped
join.
it.
They just join the call by sharing. So
Okay.
please, Ajande, please unmute your mic again and let's talk. I'm saying that you say you've not attended any physics class so far. So
Yes, sir.
what you need to know is this: we are just applying Coulomb's law formula. No, Coulomb's law formula is KQ1. Maybe you've heard of Coulomb's law before. The
Yes, sir.
formula. Okay. So Coulomb's law formula, you've heard of it. So we're applying that Coulomb's law formula. Share your few now.
Yes, sir.
That's what we're applying to solve this question. So yeah, so maybe when we keep on solving more questions, you would catch up. You are just joining, you missed a lot already. But when you keep on solving more questions, you still, I feel like you will still catch up. She gets.
All right, sir. All right, sir.
Yeah, I believe you will still catch up. So I've muted you back. So now let's move to the next example. Who else again is having issues with this? Someone that attended the yesterday class and you don't understand this thing, please give a kind emoji. If you attended yesterday class on physics and you don't understand, give a kind emoji, please. Be fast. Nobody. Okay, everybody understood, right? So everybody should give a thumbs up then, and let's move on. So now, since everybody understood what we're doing, everybody should give a thumbs up, and let's move on. So now, this is the second part of the question. Now, they say that given the diagram below, this is the second part of the question. They said, given the diagram below, find the total force on part 1 due to particle 2 and particle 3. Find the total force on particle 1 due to particle 2 and particle 3. Are you guys following me? Find the total force on particle 1 due to particle 2 due to particle 2 and particle 3. So this is particle 1. Look at this diagram here. This is particle 1. I don't know if you guys can see me. What's up, guys? Anybody's joining on WhatsApp. But this is particle. I want to adjust the camera for WhatsApp, guys. Okay, so as I was saying, we have, you say you find the total force on particle 1 due to particle 3. So now looking at this now, you see that this particle 1 here, this particle 2, this particle 3. Now force on 1 due to 2. Which direction? Forget about this 3 for now. Force on 1 due to 2. 1 is plus, 2 is plus. Boy, will they attract? No, that is gay. Boy and boy cannot attract. So it means that force on particle 1 due to particle 2, they are boy, it is gay. So it means that particle 1 will run away from particle 2, right? Because particle 1 will not want to go and prick cannot meet prick. So particle 1 will run away from particle 2. In which direction? Particle 1 will run away from particle 2 in the what do you call it? In the negative x direction. That means that the direction for force on 1, due to 2 is negative x direction, and the direction for force on 1 due to 3, force on 1 due to 3, which direction is that one? Force on 1 due to 3, which direction is that one? Anybody who wants to tell us? Comment section. Force on 1 due to charge 3, comment section. Which direction is that? Akinola, I'm impressed though. You've been answering all my questions correctly. What's your department? What's your nickname and your department? Akinola, your nickname and your department. Type it down. Akinola, nickname and department. Type it in the comment section. So now, as I was saying, force on 1 due to 3 will be moving in the positive x direction. Why? Who can tell us why? The reason why force on 1 due to 3 will be moving in the positive x direction is because there will be an attraction. Charge 1 is a boy, it is plus, it's a boy. Charge 3 is minus, it's a girl. So you should know that charge 1, which is a boy, we want to go and meet charge 3, which is a girl. Attraction. And if charge 1 is trying to go and meet charge 3, charge 1 will be moving towards charge 3 in the positive x direction. Charge 1 will go and meet charge 3 in the positive x direction. You guys understand me now? So now we've been able to justify that force on 1 due to 3 is positive x direction, while force on 1 due to 2 is negative x direction. So our both forces now, Ogene Tega, he said cannot see this thing. If you cannot see, please join the WhatsApp call. If you cannot see, the screen, join the WhatsApp call, please. Ogene Tega, if you cannot see, join the WhatsApp call, please. If you cannot see, that means your network is not good enough. Just join the WhatsApp call. This app. Sure get. Then someone can screenshot it to the group also. Someone can screenshot it to the group. Sure you get. Then someone said that they cannot hear. If you cannot hear what I'm saying, please join the WhatsApp call. Ogene Tega, you can unmute your mic. You are raising up your hand. Ogene Tega, you raise up your hand. Unmute your mic. You are not talking. Juliana, you raise up your hand. Unmute your mic. Juliana.
Okay. Good evening, sir.
You guys raise up your hand now, so people should talk.
I can hear you.
Talking.
Good evening.
Continue.
Like, I'm not on the group and I did not see any link. Like,
You're not
for
on
the
the group yet.
WhatsApp.
And check the comment section of this. Someone should be sent.
Yes, the
Faith
WhatsApp.
Man Shark, I thought I told you to send the link. Faith Man Shark, send the link now.
Yes, they sent it already.
Send it again.
Okay.
Keep on sending it again. Keep on sending it every time so everybody will see it. So that they will know how to be
Okay.
joined. So they know how to keep on. If they've talked a lot in the comment section, Faith, are you hearing me?
Yes.
If they talk a lot, that means the chat will have gone up. You send it again. You get.
Okay. Okay.
So that people will not start asking me. So please join the group. Copy the link that is in the comment section. Paste it on WhatsApp and join the group. So when you join the group finish, when you join the group finish, then you'll be seeing some of these things that it's even preferable if your friend add you. Because if your friend should add you, you are going to have access to the formal messages on the group. If your friend is adding you, but if you don't have any friend that can add you, then probably you should just join the link. So you can join the link and join WhatsApp call. If you cannot see what I'm presenting, join the WhatsApp call. Or join the WhatsApp call. That's alternative. So now who has a question again? Anybody who has a question again? Is everybody someone should solve this thing? What's the answer? Our R is still 0.2. Our R is 0.2. Our Q1 is still the same value. Our Q1 is what's our Q1? Our Q1 is E. Our Q2 is 2E, and our Q4 is also 2E. Oh yeah, so guys, what is the answer that you guys got? I'm waiting for you guys. I don't want you guys to see the answer. So what's the answer that you guys got? So everybody should unmute their mic. Everybody unmute your mic. Ogene Tega, you can unmute, you can talk. You raise your hand. Yeah, so please guys, what did you guys get? What did you guys get? Juliana, do you want to say something? Juliana, you raise up your hand now. Do you want to say something? Juliana, you raise up your hand. Do you want to say something? Juliana. So all of you are just whining me. I will remove you from this group, and because I don't know why you are raising up your hand. I am not saying anything. I will remove you. You join back. So when you join back now, I believe that by that time you will be compose yourself. So Juliana, you've been removed from the group, so you join back. So now, I was saying that what is the answer to the question? Anybody? Anybody? What's the answer to the question? Anybody? What is the answer? So nobody's giving us an answer like this. Faith, unmute your mic.
Yes.
Paul, do you have a question? If you have a question, Paul, unmute your mic. You are using a crying emoji. Paul, unmute your mic. Why are you guys using crying emoji? I am not unmuting your mic. What's the meaning of this now? Let me go and remove the people that are stressing me out. Oh, I'm removing from the group also. Not use crying emoji, then that means you don't understand. Then be ready to unmute your mic immediately. Or you are leaving the group. So that I will not be stressing me. I will not be. If you use crying emoji, it shows you don't understand something. Then unmute your mic and talk. If you are not now talking, then that means I will remove from this place. Oluwa Fifehan mi Rodiat. You also your hand. Do you want to say something?
Yes, sir. Good evening, sir. So how
Yeah,
do
the
you know
first say
that
nothing.
Q1 is equals to E and Q2 is equals to 2E? Like, is it given in the
No,
question?
it's already they've given us already the question. See, it's there. See, can you
Okay.
see it? I like it for you.
No,
Can
okay,
you see
okay.
it?
Yes, sir.
Can you see it now?
Yes, sir.
Yeah, it's already there. Yeah, yeah. So which other question do you have again? Where's again have a question? They've already given us. They said I should take your R to be R is 0.2. Q1 is E, Q2 is 2E, and Q4 is 2E. So please, guys, what was the answer to the question? To that question, what's the answer? Faith, unmute your mic and tell us the answer. Or tell us how we're
I'm
going to
still
solve it. Unmute your
solving
mic.
it.
Faith. After all, kilo day. Now we're doing one solve. Just put the values now. Do your table. Put the values. Abi, show love funny. So your original components for F1 2. First on 1 due to 2. First on 1 due to 2. First on 1 due to 2. The original component is is minus KQ1 Q2 over R square. R square is the distance between 1 and 2, which is big capital letter R. Then the vertical component for F1 2 is 0 because F1 2 is not moving along the y-axis, it's moving along the x-axis. Then for the other force on 1 due to 3, the horizontal component will be K Q1 Q3 over R square. Then this one now, the first on 1 due to 3, the direction is positive because Q1 will go and meet Q3 because Q1 is a boy, positive, Q3 is a girl, negative. So boy will go and meet girl. So Q1 will go and meet Q3, which is positive x direction. So Q1 is moving in the positive x direction to go and meet Q3. So the direction for F13 is plus on the horizontal. Then for the vertical is also 0 because F13 is not moving along the vertical, it's only moving along the horizontal. So having said that, all you need to do is now find the total. What's the total x? Total x part. You do that one. What's the total y? Total y is 0. What's total x? That's what I want you to do. Check it. So let me send this. Let me send the table to the group. So I'm still waiting for answer, guys. I'm still waiting for the answer. I'm still waiting for the answer, guys. So who wants to unmute mic and tell us the answer? Is Tobiloba in this on this call? Tobiloba, are you on this call? Tobiloba, are you on this call? Tobiloba is not on this call. So Faith, are you done now? Unmute your mic. Are you done now? Please, you can join on WhatsApp.
Almost.
It's not what you join to Google Meet. You cannot see. Join on WhatsApp. Faith. Oh yeah, someone should
Yes.
talk. Mr. Bora, who on this call? Mr. Bora, who on this call? Akiola, unmute your mic. Akiola, unmute your mic, please. Akiola, unmute your mic.
Yes.
Yeah, what's your own answer? Be fast now. What's your answer? Why you guys have calculator? Don't you have calculator? Don't you have book? You guys should press calculator now. Eh? You guys should press the calculator. Or you don't have book. Google Meet, guys. Google Meet, guys. What's up, people? Please mute your mic. If you're joining to WhatsApp, mute your mic. Google Meet. Oh yeah. Voila.
Um,
So what is giving us answer like this? Who wants to give us answer now? Nobody. Okay.
sir,
Well, I'm not happy with you guys. Faith and all of you, I'm not happy with you guys. I'm not happy with you guys. Because
sir,
just what
sir,
happened?
Um, what I did was 9.0 times 10 raised to power minus 27.
That's all you got. You're meant to get 9 times. You're meant to get this value. 9 times 10 to the power minus 25 newtons. Press your calculator very well. F12 on the x should give you F12 on the x should give you minus 1.15 times 10 to the power minus 24, and F13 on the x should give you 2 times 2.05 times 10 to the power minus 24. Then when you add them together, you're meant to get 9 times 10 to the power minus 25 newtons along the x
I
axis.
got I got 9 times 10 raised to power minus 25.
That's what you got, Taru.
Yes.
So you guys should just press your calculators. The values are already here. Just press your calculators and get the answer. So now that's that about that. So now let us move on. Before I move on, do you have any challenge again before I move on? Any challenge before I move on? So now write this statement down. I want to dictate for you guys. Write this statement down. Please and please. I want you guys to write this statement down. What's up, guys? Please mute your mic. What's up, guys? Mute your mic. If I join your WhatsApp, please mute your mic. If I join your WhatsApp, please mute your mic. Who is this person like this? Who is this? What was this number? If I join your WhatsApp, please mute your mic. Yeah, so now let's continue. So as I was saying, guys, I said you should write this statement down. You said that if they ask you to find the equilibrium of forces, write it down. Write this subtopic. Equilibrium of forces. Write it down in your notes. Subtopic. Equilibrium of forces. Subtopic. Equilibrium of forces. Now, if you are asked to find a particular point where you can place a third charge such that the net force acting on that charge will be 0. That is what they call equilibrium of forces. Equilibrium of forces is I'll come again. Equilibrium of forces is when you want to find a particular point where you can place a third charge such that the total force acting on that third charge will be 0. Have you guys written that down? Equilibrium of forces, give a thumbs up if you have written that down. You can give a thumbs up if you have written that down. You can give a thumbs up. So equilibrium of forces is the point whereby you can place a third charge such that the total force acting on that third charge will be 0. So now looking at this now, say let's talk about equilibrium of two forces on a particle. Consider charges Q0, Q1, and Q2. We want to place Q0 such that the net force on Q0 due to charges Q1 and Q2 is 0. The following arrangement are possible. Now, I want you to draw this diagram down. Please, you guys should draw this down. What's up, Charlotte? You know, if you're online, please, someone should screenshot this thing and send it to the group. Please, draw this diagram down. Let me highlight it. Draw this diagram, draw it down. Oh, yeah. Have you guys drawn it? Please give me a thumbs up if you are done drawing the diagram. Give a thumbs up. If you are done drawing that diagram, give a thumbs up. If you are done drawing the diagram, give a thumbs up. So now, this is the first arrangement that is possible. The first arrangement is when you place the third charge Q0 in between. Someone is asking a question. Someone said in the equilibrium, is it only on that charge that the force acting on it is 0? Or the system? It's only on that charge. The force acting on that charge, on that third charge, due to the other two charges, will be 0. That is the equilibrium of forces. So I'm not saying that you should draw this diagram. If you draw this diagram, this is one arrangement. The arrangement that happens here is that we are placing Q0 in between Q1 and Q2. Take note of that. So now, if Q1 and Q2 are of the same sign, Q0 is placed in between Q1 and Q2, as shown above. such that the force on Q naught due to charge 1 and the force on Q naught due to charge 2 cancels out at a particular distance x. Full stop. They will cancel out because the two forces will be moving in opposite direction, or as per se, Q1 and Q2 have the same sign and Q naught is the only charge with opposite sign. Therefore, attraction will happen between Q naught and Q1. Same way, attraction will happen between Q naught and Q2 to give FO2. So what I'm trying to say is this. If you cannot see the screen, someone should screenshot to this. I've already said that Shaluzina and Co. People should screenshot this to the group for people that cannot see the presentation. Some people's network is not good. So please screenshot. You guys should screenshot and how like this. Please kindly screenshot this thing to the group so that people that cannot see this thing can access it. Thank you. So now, what we're trying to say is this. If Q1 and Q2 are positive charge, you can write, maybe you just write this. Let me just remind this for you. Write this in your notes. If Q1 and Q2 are positive charge, are of the same sign. If Q1 and Q2 are of the same sign, place Q naught in between Q1 and Q2. I repeat. If Q1 and Q2 are of the same sign, place Q naught in between Q1 and Q2. That is all these things I wrote here. That's the summary of it. If Q1 and Q2 are of the same sign, place Q naught in between Q1 and Q2. Are you hearing me now? Now, the second scenario is this. Right now, number 2. Right. Number 2. If Q1 and Q2 are of opposite sign, write this statement down. If Q1 and Q2 are of opposite sign, I guys writing that. Please give a thumbs up if you are following me now. This is looking like I'm talking to myself because nobody is reacting. All of you are just doing like zombie. Nobody is reacting. Nobody is doing anything. Everybody is just there, like log of wood. So, all of you guys are just there, like log of wood, like signboard, like zombie that is just moving in that direction. Scalar quantity. So you guys should be talking now. So I can find direction together. Let me just look like no reaction, no comment, nothing. It's not very bad. I will end this call now. Kigani. Ogini. So it's as if I'm just talking to myself and it's just frustrating. So now as I was saying, I said that number two, if Q1 and Q2 are of opposite sign, place the third charge beside the smaller charge. If Q1 and Q2 are of opposite sign, place the third charge beside the smaller charge in magnitude. Place the third charge beside the smaller charge in magnitude. What I'm trying to say is this. Assuming Q1 is +2 and Q2 is that person that is coming my class, I will go and remove him from the corner. That one that not mute his mic. Don't stubborn. You unmute mic without permission. You can react. You can use comment section. Some of you won't unmute mic. It's not like your background is noisy. You're still unmuting mic. Your mute mic. It's not like you want to say anything tangible. You want to offer any value to us. You don't have value. You want to offer us. You're unmuting mic. You don't have any question. You don't have any value. What's your problem? So now, as I was saying, if Q1 and Q2 are of opposite sign, place the third charge Q naught at the beside the one that has smaller value. So I want to give you an example now. I said, assuming Q1 is, let's say, assuming Q1 is 5 microcoulomb and Q2 is 10 microcoulomb. Which one is bigger between Q1 and Q2? Please use your comment section. Which one is bigger between Q1 and Q2? Today nobody is talking. Log of wood. Ah, Ugao. People will do like log of I said that if Q1 is 5 and Q2 is 10, which one is bigger? If Q1 is plus 5 and Q2 is plus 10, which
10
one
is
is bigger?
bigger. Q2.
Maybe someone should miss mic
Q2.
than talk.
Q2.
I don't understand why everybody's not
Q2.
talking like this. Class is just boring
Q2,
and annoying.
Q2.
Q2.
Me, I hate
Q2.
boring class. Now I will leave this call. Look, Mobile. Ah, and
Me
now
too,
if you guys
sir.
are doing like zombie here, me, I will
Q2
leave
is
this call.
bigger.
Between so I said that if Q1 is plus 5 and Q2 is plus 10, which one is smaller? Which one is bigger? Q1 is smaller, right? Q1 is plus
Q1 is
5.
smaller.
That means that you are going to place the third
Q2
charge
is
Q
bigger.
naught.
Q2 is bigger.
You are going to place your third charge Q naught at the side with smaller value. And since Q1 has a smaller value, it means that the third charge Q naught will be placed beside Q1. Look at the screen now. You can clearly see that I placed you can clearly see that I have placed what? I have placed Q naught beside Q1. Why am I placing Q naught beside Q1? It's because Q1 is smaller than Q2. Q1 is smaller than Q2. That is why that although differ from let me puff. So I place Q naught beside Q1 because Q1 is smaller than Q2. So you get. So that means that if the distance between Q1 and Q2 is L, that means the distance between Q1 and Q naught will be X. I want to now find the value of X, which is the distance, which is the point where we are placing the third charge. Now I want to ask you guys a question now. I'll call someone randomly. Assuming Q1 is greater than Q2. Assuming Q1 is greater than Q2, like assuming Q1 is bigger than Q2. Obviously, I'm going to place Q naught where? Who can tell us where we place Q naught? If Q1, assuming Q1 was greater than Q2,
Beside
where are we going to
Q2.
place Q naught? Anybody?
Beside Q2.
Beside Q2.
Q2 beside Q2.
Who place it beside Q2, right? So we place it at this side. That means from here to here will now be X. Good. So I want to now ask you a final question now. Assuming Q1 is minus 4. Assuming Q1 is minus 4 Coulomb. Assuming Q1 is minus 4 Coulomb. And Q2 is plus 3 Coulomb. Assuming Q1 is minus 4 Coulomb. And Q2 is plus 3 Coulomb. Which side will I place the third charge Q naught? Anybody?
Q.
Q1.
Chalosino,
Q1.
please open mic and
Beside
talk.
Q1.
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 Chalosino, omit your mic and
Q1.
talk. Chalosino,
Q1.
which side am I going? I said that if Q1 is minus 4 Coulomb and Q2 is plus 3 Coulomb, which side will I place the third charge Q naught? Chalosino, answer me.
Q1.
Eh?
Q1.
Okay, is Faith Manshi, Faith Manshak, is
Yes.
she correct? Is she correct?
No.
Why do you say she's not correct?
Because according to the second law of the equilibrium
Please
process,
speak louder, speak louder, abeg, good day.
according to the
I'm
second
hearing you.
law, if the two charges Q1 and Q2 have opposite sides, you place the third charge at the side with the lowest magnitude. So you will ignore the signs, but the
God will bless you.
magnitude
God will bless.
remains.
God will bless you. God will bless you. I said it already. It's even here on the screen. Place the Q naught beside the smaller charge in magnitude. Faith, God will really bless you for this. God will bless you for this. So according to the statement, you guys should follow the statement I gave you. Place Q naught at the side. Please let's clap for her. Place Q naught at the side with the smaller charge in magnitude. So now I tell you that Q1 is minus 4. Q2 is plus 3. You will ignore the sign because when you are saying magnitude means ignore the sign. Magnitude means what is the actual value. When you ignore the sign, that is what they call magnitude. She gets magnitude means ignore the sign and give me that. So in magnitude, according to magnitude, if it's not the sign, that means Q1 will be 4 and Q2 will be what? 3. Now between Q1 and Q2, which one is smaller? It is Q2 because Q2 is 3, Q1 is 4. If you ignore the sign, so that means that you place the third charge Q naught at the side, you place it beside Q2 because Q2 is 3, which is smaller than Q1. Do you understand this thing very well now? Please give a love emoji or a thumbs up if you understand what we're doing now. Give a love emoji or a thumbs up if you understand. So thank you. So if you don't understand, give a crying emoji. If you don't understand what we're doing, give a crying emoji. So this is what I was explaining here. Sure you get. Now I gave a scenario. I said, okay. So I was like, okay, if Q2 is less than Q1, then okay, then Q0 must be placed beside Q2, which I've explained in details. So so yeah, now normal, you know, this is like I said, these are our past question. Like I said, I was like, if you want to know the full reasons, come to Dayspring or check holiday. I have to give a page number. Holiday. So if you check holiday page 569, holiday page 1569, that's the reference I gave you. Your holiday textbook page 1569 under equilibrium of two forces. Then you see you will be able to read more on this. So thank you very much. And that's my number. So now so now let's use the two principles above for examples below. So now let's come to this. Let's come to the example here. So that look at this example 1.6. Someone should screenshot that one and send it to the group. So example 1.6. Holiday, not holiday. Someone said holiday. But holiday. Some of you have never read that book textbook before in your life. Which is holiday call. You holiday don't enter your head. Miss semester breaking. So look at this. Example 1.6. Given that example 1.6, given that Q1 is plus 8 and Q2 is minus 2. Q1 is plus 8, placed at 0, 0. So Q1 was placed at, I think I drew it. Yeah, this is it. Q1 was placed at 0, 0. Q2, which is minus 2, was placed. Sorry, this should be Q2, please. Is a typo, so you guys can correct this. If you are drawing this diagram in your notes, please correct this one. This one is meant to be Q2, not Q3. So Q1 was placed at 0, 0, and Q3 was placed at L, 0. Q3 was placed at L, 0. Get. So now, are you guys with me? Yes, thank you very much. So now, that means distance between Q1 and Q3, distance between Q1 and Q2 is L. Distance from here, from 0 to L. That distance between this one is L. Now, since the sign of Q1 is plus and Q2 is minus, it means I will place the third charge Q0 at the side with smaller magnitude. So between Q1 and Q2, I want to guys to submit your mic. Between Q1 and Q2, which one is smaller? Q1 is plus 8, Q2 is minus 2. Which one is smaller? Anybody?
Q2.
Q2.
Q2 is smaller, right? If you ignore the sign, Q2 is smaller. That means I will place the third charge Q0, which I've done here for you. Let me your mic back. Oh yeah, Odeo. If you don't say your background is noisy, I beg don't unmute your mic again. Enjoy your home, or else we will remove from this group so you go and be with your homes, with your family. So as I was saying, Q1 is plus 8, Q2 is minus 2. So if you ignore the sign, Q2 is smaller. That is why I place this Q0 at this beside Q2, because this Q2 should be Q3, this Q3 should be Q2. Please take note of that. So that's why I place Q0 beside Q2. Since Q2 is smaller, than that's why I place this Q0 beside Q3. Here you get. So now, looking at this now, so looking at what I did here, you can see that I placed Q0 beside Q3 because Q3 is smaller than Q1. Now, distance between Q3 and distance between Q2 and Q0 will be X. So distance from here to here is X. You can see distance from 1 to 2 is L. So who can tell me if distance from 1 to 2 is L and distance from 3 to Q0 is X? What's the distance between 1 to Q0? Distance between 1 to Q0 will be what? L plus X. Do you agree?
L plus X. Yeah.
If distance between Q1 to Q0 will be L plus X. Do you understand my point now? So that is L plus X. So now, someone should screenshot it and send it to the group. Now, someone should just screenshot this thing and send it to the group. Shallow, you know, or Faithman Shark, anybody. You guys should screenshot and send to the group. Let me zoom the diagram very well so that I can see the diagram very well. Some people say they cannot see the diagram. So I'll zoom the diagram here. So I believe that everybody can see the diagram now. Can you guys see the diagram now? This diagram. So please, you guys should do the screenshots and send it to the group. So I said that when you're doing diagram with your notes, change this Q3 to Q2. I said that one already. Change Q3 to Q2. Thank you. So now, how do you now solve? Since we know that after you're done doing this, after you're done placing the Q naught at the side beside Q3, now the force on Q naught due to Q2 will cancel out force on Q naught due to Q1. They will cancel out. They will be going in opposite direction, so they will cancel out. Now that means that force on Q naught due to Q2 equals to force on Q naught due to Q1. That's the meaning. It means force on Q naught. So this is what we are saying now. Force on Q naught due to Q2 equals to force on Q naught due to Q1. Write that one in your notes. Write your notes. Force on Q naught due to charge 2 equals to force on Q naught due to charge 1. After following this rule, force on Q naught due to charge 1 will be equal to force on Q naught due to charge 2. So if they are now equal to each other, it means what's formula for that? Means that force on Q naught due to charge 1. Force on Q naught due to charge 1 is KQ naught Q1 over R square. And the R square, what's the distance between Q1 and Q naught? Force on Q naught, someone I should come again. Force on Q naught due to charge 1. Force on Q naught due to charge 1. The formula is, we use Coulomb's law. The formula is KQ naught Q2. Sorry, force on Q naught due to charge 2. Force on Q naught due to charge 2 will be KQ naught Q2 over R square, where R is the distance between Q naught and Q2. Now, what's the distance between Q naught and Q2? Distance between Q2 and Q naught. Distance between that is X. Do you agree? Distance between Q naught and Q2 is X. So that is why you can see from here that force on Q naught, this formula here, can you see? KQ naught Q2 over R square. Our R is X. That is distance between Q naught and Q2 is X. That is R square. That is X square. Now, force on Q naught due to Q1. It will be KQ naught. It will be KQ naught Q1 over R square. But R this time around, what's the distance between Q naught and Q1? Distance between Q naught and Q1 is L plus X. Is L plus X. She gets. Distance between Q naught and Q1 is L plus X. So that is KQ naught Q1 over R square, where R is L plus X. Then the other one is KQ naught Q2 over R square, where R here is what? X. So now you know they will be equal to each other. You cannot agree that K will cancel K. God will bless you, Akela. I saw your comments. He said Q naught to cancel out. God will bless you. Q naught to, that means we don't even need. That means we don't even need. It's not to the economy of forces. You don't even need the value of Q naught. You don't need it. Since the Q naught will cancel out. If I want to find the point where the total force on Q naught will be 0, it means Q naught. This means since total force is 0, it means Q naught will cancel out. The forces are equal to each other, so they cancel out. So Q naught cancel Q naught. K cancel K. Abby. Now what do you have left? You have Q1 and Q2 left. Now what is the value of Q1? Again, guys, say you are lost. I already told you. Force on Q naught due to 1 equals to force on Q naught due to 2. This is what we are using. Force on Q naught due to 1 equals to force on Q naught due to 2. Forget about the paparazzi I did here. Forget about this paparazzi that I did. Forget about this paparazzi that I've done here. I did some paparazzi. I did all these ones are paparazzi. Forget about the paparazzi. All these ones are just explanation. This is the end game. Total force on Q naught due to charge 1, which is this KQ naught Q1 over R square, where R is L plus X, equals to force on Q naught due to charge 2, which is KQ naught Q2 over R square, where R is X. Now, if Q naught cancel out and K cancel K, what do you have left? You'll be left with Q1 over L plus X square, then Q2 over L over X square. Then what? Now the question is this: this Q also cancel out, this Q also cancel out. So what do you have left? You have 8. So Q will cancel Q. 2 here 1, 2 here 4. If you divide both sides by 2, you have 2 year 1, 2 year 4. So you're going to have this. Do you guys agree? You're going to have 4 over n plus x all squared equals to 1 over x squared. Now, I want to solve for x, which can lead, this one will lead me to quadratic equation. But how can I avoid using quadratic equation? You know, when we're doing normal school class, before school went on break, from people that attended normal discipline class, I told you guys before that if you want to solve questions like this, always find the square root of both sides. So that it will be so that you know how to do, you know how to be doing quadratic equation, almighty formula, which will take your time. Just square root both sides. By the time you do square root of both sides, this square and this down part will go away. So when you do square root of both sides, the square will go away. So you're going to have, what is square root of 4? Square root of 4 is 2, right? Square root of 1. Square root of 1 is 1. Square root of s squared is x. Square root of x l plus x all squared is l plus x. Are you guys following? Now if you cross multiply, what do you have? You have 2x equals to l plus x. If you cross multiply this, you have 2x equals l plus x. Whenever we're looking for the value of x, so since I'm looking for the value of x, 2x minus x, what would that one give us? 2x minus x, what that is to give you x. So x equals to what? L. X equals to L. So I've gotten my x to be L. So if L is 10 meters, that means x to be what? 10 meters also. So now that I've gotten the value of x, from the diagram, the net force will be 0 if and only if Q naught is placed at the point L plus x beside Q naught, which means at the point x equals to L. So that's what we're trying to say. So if once write it in coordinate form now, you now say the Q naught, which is the proton, should be placed at the point at the position 2L, 0. Then the net force will be 0. So what I'm trying to say is this. You this 0, 0. This is L, 0. This place is what? L plus x, 0. So if x is L, that means L plus L is 2L. That means you are going to place Q naught at the position 2L, 0. Thank you very much. So if you don't understand this thing, you can ask. Someone is asking a question. Actually, but this is a question. This is a question I ask now. What if what if the charges are placed in 2D? Olorun is saying that what if the charges are placed in 2D? If charges are placed in 2D, one thing you should do is this. Before something can cancel out, are you following me? Before something can cancel out, they have to, like, the two charges have to be they have to be like be facing each other. I don't know if you understand my point. They have to be facing each other. All those things are very, very important. So most times, this kind of questions, they always give you in 1D. Are you hearing me? You always give, this one is 1D means one dimension, one direction. You can see that this one here, you can see that it's only on x axis. It's not on x and y. If you put Q1 and Q2 on x, you must now put Q3 on another position on y axis, and you are expecting it to go to 0. It's not go to 0 now. They will not cancel out. The only way they can cancel out is for Q1, Q2, Q3. All of them should be on the same axis. Are you following me now? So that they can cancel out. If they are not on the same axis, they will not cancel out. So I think I've answered your question. Ogenetega, you are right. Double the distance of Q1. Shannon. He said, if I said I'm lost, later on, you're the one that is giving us the answer. That shows you are a genius. Ogenetega, Okagbera, Okagbare, Abi, what's that? That's how Emily went to change her name. Emily changed her name from Isigwe, Ngozi Ugo, Isigwe, Ifunaya, change it to Emily. It's not easy. If I want to marry an Igbo girl like this, they say, Marvie wants to wed Ngozi Ugo. What they will call the name finish? It is don't come out. So I just wanted to catch quick small so that every tension will die down. So please, I believe that you guys have screenshotted this thing to the group. So people, I want to, and if you don't understand this thing, please give a kind emoji. If you don't understand this thing, give a kind emoji and unmute your mic so that you can tell us the parts you don't understand in this stuff. I don't think anybody gave a kind emoji. That means everybody understood this thing. So now please, you guys write this question now. So please, I'm in this class. this is your classwork. I will not show you the solution. So this is your classwork. If someone should screenshot this thing to the group, this classwork, crop that part alone and send it to the group. That's your classwork. Please. Please that so, or someone can send it to the comment section. Or someone should send it to the group actually. The group is better. Copy it and send it to the group, please. So that's your classwork like that. I'm waiting for you guys. Oh yeah, nobody's commenting anything safe. Someone should talk. Someone should comment something. Someone should Malade. Yeah, someone should type my name there. Someone should comment something. You cannot comment anything, type my name. Say my name. Who knows that DJ Kali song? Who is this person? Who is this? Who is this? I am that I am. I swear I can't take that. What's that aberration? In fact, how did this person know my? How did you know that? Who is this? I am that I am. Please message me on WhatsApp. I want to know. I want to know the face behind this. I want to know the face behind this. I am that I am. I am. If you don't message me on WhatsApp, I will remove you totally from this call. I will block you from this call. You know, you will never join this call again. What's that? What's the name of that one? And I said I don't like that. Message me now. I am that I am. Message me now on WhatsApp. I want to know the face behind this. I am that I am. I want to know the face behind this. Immediately, with immediate effect. Or else you will not join any of this call again. Ever. You will not join tomorrow's class. So someone said that it's very hard. Ogene, what is hard? Ogene, unmute your mic. Ogene Tega, what is hard? Ogene Tega, yeah, now unmute your mic now, Ogene Tega. Ogene Tega. It's not hard. You see that 3 charges lies on x-axis. The positive charge Q1, which is plus 10, is placed at the position x equals to 1 meter. And negative charge Q2 is placed at the origin. That's 0,0. So that means you place Q2 at 0,0. You place Q1 at 1,0. That's plus 1 on the x. Now, where must the positive charge? Where must the third charge Q3 be placed on the x-axis so that the resultant force will be 0? So now, guys, before I end this call, where should we place the third charge? Since Q1 is plus 10 and Q2 is minus 2, the sign are opposite. The sign are not the same. I give you a rule. If the sign and Faith, please unmute your mic and explain this thing to us. Faith, Manchak.
Yes.
Unmute your mic and explain this question to us. Some people said that. Someone said that it's hard. Okay, Tega said it is hard. So please explain this question to us.
Okay. She said that is the second law of equilibrium of forces, that if you have 2 charges of opposite signs, then you will place your third charge at the side with the lowest magnitude, meaning that you are going to ignore the signs and only focus on the numbers, which is 10 and 2. So you are going to be placing your third charge at Q2.
Beside Q2.
Beside Q2.
Exactly. So that means distance between Q2 and the third charge will be x, and distance between Q1 and Q2 will be what? Faith, answer. What will be the distance between Q1 and Q2? Since Q2 is placed at the origin 0,0 and Q1 is placed at position 1,0, what will be the distance between Q1 and Q2? Faith. What's the distance between 1? Correct. The distance between Q2 and Q0 will now be what? X. So we want to find the value of x, right?
Yes.
And to find the value of x, I already gave you this is the formula here. Where is it? This is it. That the force on Q3 due to Q1 equals force on Q3 due to what? Due to Q2. So the force will be equal to each other. So it means that the force on Q3 due to Q2 will be equal to force on Q3 due to Q1. Let me show you guys the diagram, but you go and solve it yourself. So look at this diagram that I drew here now. So we have Q1, we have Q2. I've drawn the diagram for you here. We have Q1, we have Q2. Now, Q1 is placed at 1,0. Q2 is placed at the origin. Now, we are putting Q3 beside Q2. Why? Because Q2 is smaller than Q1. So we are placing Q3 beside Q2. So distance between Q3 and Q2 will be x, which means this will be position minus x, 0. Thank you very much. So now all you need to do now is the first because F31 equals to F32. What's formula for F31? KQ3Q1 over R square. What's formula for F32? KQ3Q2 over R square. So you can K will cancel K out. Q3 will cancel Q3. They don't give you the value of Q3, so they'll cancel out. So what you're going to have left is just solve it like the way we solve this one. The same way we solve this one, solve it. So please and please, I will not show you the answer. So please, thank you very much. So I'll stop sharing my screen now. Thank you very much. Thank you very much. So with this 3 points of mine, I believe I've been able to explain equilibrium of forces and all for you. So with this, we are done with everything on forces. So all you need to do is solve this question. So let me I want to give you another. The answer to this question that I asked to solve. The answer to this question is x will be 0.809 meters. That'll be your x. Now the position will now be minus 0.809, 0. That's the position. Then I want to do something now. I want to give you guys more questions to do. So I will share my screen back again so that Chaludino or Faith, anybody can share the screenshots. I don't want you guys to see some part of the distance, so but I'm sharing my screen back now. If you need these materials, you can pay for the past question. That's 4,000 naira. You can contribute with your friend and buy it together so you guys can read it together. But you're not allowed to fully scan or fully photocopy it. This is illegal, and if you are caught, you face investigative units. Flow. I know some of you don't know what they call flow. God will not let you know flow till you got it. So now, I'm sharing my screen again now. So I want you guys to show this thing. So these are some questions that I want you to do. So more questions. I want you to do more questions. I've already given you the hint. This one says the nucleus in an iron atom has a radius of this, and contains 26 protons. What is the magnitude of the positive force between the two protons that are separated? Blah, blah. This one is just Coulomb's law. I gave you the hint already. And femtometer means 10⁻⁻15. Then look at the second question. They say, what is the magnitude of gravitational force between those two protons? Use this formula. You know the formula from last semester? F equals to gm1 m1 m2 over r squared. Do you remember this formula, guys? Give a thumbs up if you remember. Formula for gravitational force from last semester. gm1 m2. So they say we find the value of the gravitational force between the two protons. So use this formula gm1 m2 over r squared. M1 will be the mass of the proton. M2 will be the mass of there are two protons. So M1 and M2 are both protons. And what's mass of a proton? Anybody? Who remember? Who can tell us mass of a proton? Etik Bagbe? Okay. So please correct this thing. This one should be F equals to GMP square. There should be a square here. MP square divided by R square. So you guys don't know the formula for mass of a proton again. What's mass of an electron? Hold on, my God, If you don't know the mass of a God bless Akinla, 1.627 times 10⁻⁻27 kilogram. What's mass of an electron? Mass of an electron. You better chemistry last semester, atomic theory. How you take past chemistry self? Okay, they've not released your results. My bad. So mass of a proton. What's mass of an electron? 9.11 times 10⁻31. That's correct. We can access it. So the top question here says find the ratio of the electrostatic force to that of gravitational force between those same two protons. And I gave you the hint to solve it. The electrostatic force is KQ1 Q2 over R square. Gravitational force is GM1 M2 over R square. So when you do the ratio, FE divided by FG, so over to you, you do that one. These 3 questions, do it and send the solution to the group. Sure you get. Thank you very much. The hint is already there. So thank you very much. I believe that we are all on the same. I believe that we're all on the same page. So thank you and God bless. So please, if you want to buy the material, you pay down. It's 4,000 if you are in school, and the obvious that you can get the fees material if you're in school. It's 4,000. If you're not in school, you pay down so that I can get it immediately. You come back, you get that copy immediately. Come back from break. Also, if you want to pay for this, if you want to make inquiries about the tutorial, you can message me personally, or you message Miss Good, Miss Urala. Will tag her on the group. You can let me send the group link again to this place so that people that are not on the group link can get. So please, you can message me if you want to make inquiries about the tutorials. If you want to join the class fully for the semester, you can make it. And if you want to just join for the online class alone, try this break. Okay, you can also message me. It's good for that. So whether past question, whether online, whether physical, whether all the classes generally this semester, you can just reach out to me personally or to go so that you can make inquiries. If you want to make payments too, you can make inquiries for all those things. So thank you, love you, and God bless you guys. I want to go and cuddle my babe. Sorry, my bed. Whether for three, whether for two, I'm gonna cuddle my bed. So thank you very much and see you on the group. So please go and so I believe you guys have screenshotted this thing to the group. So please go and deal with all those 4 points I've given you. And thank you very, very much. So let me stop sharing the screen. Thank you. So thank you. Bye for now. I also stop recording now because so I'll upload everything in the midnight. I'll upload all the 3 videos. I'll be all the this is day 3, so I'll upload all the 3 videos on the this thing and label it very well so that no, I think this is day 4. So all the 4 videos I'll upload it on YouTube. So